Now, one thing is very, very important to remember. Read the question. It is very important that you understand the question, you read the question, and the question makes sense, what is going on. A medical research is studying the relationship between age, so studying the relationship between age and volume of blood pumped by each contraction of the heart. So there is a relationship between age and volume of the blood pumped. So age is X and the volume of the blood pumped by the heart is Y milliliter. So the researcher obtained the following data from a random sample of 8 patients. We have 8 patients. So this is 1, 2, 3, 4, 5, 6, 7, 8. And each of the patient, we took the age of the patient and we took the amount of volume that the blood is pumped from the heart. And we have these information already done for us. The summation, if we add up all the values of X, we'll get this summation of X, then we have sum of X, summation of Y, and on and on. We have all the information given. So the first thing that we have to do, we have to calculate sum of Y. So now remember the formula for sum of Y. Sum of Y is equals to summation of Y squared minus summation of Y whole squared divided by n. That is the formula for sum of Y. Remember, there is a difference between sum of Y and summation of Y, and there is a difference between summation of Y squared and summation of Y whole squared. So let's put down the values. The first of all, we know the values of summation of Y whole squared. It is 39418. 39418. And we also know the value of summation of Y. Summation of Y is 560. And we have to do whole square of that, and there are altogether 8 data, so we have to calculate this. So this is going to be 39418 minus 560 whole squared, so this is going to be whole squared, divided by 8. So the value we get is 218. Question number B is calculate the product moment correlation coefficient. For short, it means correlation. That's what it means. So the symbol for correlation is R. So question number B is correlation equals to, this is the formula, sum of xy divided by square root of sum of x multiplied by sum of y. Now, in order to calculate this, we need some values, and the values are already given. If you check here, the sum of xy is minus 710, square root of sum of x is 2587.5 times sum of y is going to be 218. So this is the value of the correlation. So let's calculate what it is. So first of all, let's do what is downstairs. So 2587.5 multiplied by 218, and if we do square root of that, and it turns out to be 751, and let's divide. So minus 710 divided by the answer that we just got, and it is minus 0.9453. Now, one thing is important. Correlation has to be between -1 to 1. Correlation is basically the relationship between two data. We want to know whether they're directly proportional or inversely proportional. That's it. If the correlation value is positive, it means they're directly proportional. Or if it is negative, as it is in this case, it means they're inversely proportional. That means the relationship is opposite. So it means if age is more, if a person is older, then the volume of blood would be lower. So that's what it means. Inverse. Directly proportional means if one increases, the other would increase. Inversely proportional means if one increases, the other would decrease. Now, almost always, you have to write down some sort of an interpretation, some sort of an explanation of what is going on. And this is very, very important that you understand this. This itself tells you whether you understand statistical concept or not. Interpret your value of the correlation coefficient. So you have to interpret. So there is a rule for this. The first thing you write, what type of correlation it is. So you write whether it is positive or negative, and then you write what the strength is. if it is closer to 1, the strength is strong, as it is in this case. So we can write it is a negatively strong correlation. So that's the first thing. The next thing you have to write down, you have to write down the thing in context, as inversely proportional happens, how it works. So you have to mention older people will have uh, lower volume of blood pumped to the heart. So older people have lower volume of blood pumped, and they mentioned by each contraction, by each contraction of the heart. So that's what it is. The next question deals with regression. This is one question where the correlation and regression sum is given in the same question. So let's continue. The researcher believes that a linear regression model is basically an equation where we have two variables, one x and y, and we find the direct relationship between them, may be appropriate to describe these data. So state, giving a reason, whether or not your value of correlation coefficient supports the researcher's belief. Now, you have to remember there is a strong correlation. That means it supports. And you have to write this down in context. So, in context, it would be yes, it is a strong correlation. Remember, regardless of positive or negative, the value itself, whether it is closer to 1 or -1, that tells us whether it's a strong correlation. So it is a strong correlation. So whether or not your value of correlation supports the researcher's beliefs. So yes, or so it supports the researcher's belief.